Hi, I'm Matt Inwood, and here to talk to you about web scraping for fun and profit, and I don't have any profit for you today. So, generally speaking, anything you can scrape from the web you can do on your own, but as everyone here would know, we like to automate things, we like to program things to do it, and typically like one of the projects I have out there right now, I've spent more time working on it than I probably have gained on doing it, but it's been a lot of fun and I've learned a lot. So generally speaking, what is WebDriver automation? A lot of different things that you can do with it. We do a lot of testing at my current employer. I've done data mining, web scraping kind of thing, which is the focus of this talk. And you can do any kind of AI interaction, so anything that you can interact with, you can program something to do. So I have one deterministic game here that we'll go over that can be solved, played through automatically. One of my projects was to build a more advanced one. If you've followed anything like Deep Blue from back in the 90s, AlphaGo, anything like that. And then Nefarious Deeds, if you want to do anything that I wouldn't recommend. Which brings me to legal concerns. Web scraping is a little bit of a gray area. I'm not a lawyer. Don't take any of this as legal advice. But generally, if it's publicly available, you're not really stealing anything. But you do run the risk of abusing their terms and conditions. You could, if you do too much, you might DDoS them on accident. I may have done that to my own employer before. So be careful. When in doubt, don't do it. The things you'll need to get started in decreasing orders of obviousness. You'll need Python, or really anything that uses Selenium, but most of us here are using Python, I assume. You'll want to install Selenium. Then you'll need a browser. I typically like to use a different browser than the one I use for my actual browsing, just to keep things a little segregated. Helps when doing some of the research on it. Then you'll need a WebDriver installed. I don't go through the details in this talk about it. It's a little different depending on your system, but there's links on my slides that will tell you where to go for Firefox and Chrome, and I think most other browsers have something out there. So the first example is a game called Set that I played with my friends a lot, and about a year or two ago, I think New York Times put up a digital version of this on their site. And the general concept of the game is you put these cards out in front of you, and people have to find matches on 4 categories: color, number, pattern, and shape. And either have to all be the same in each of those categories or all different. So one example, 1, 2, and 3 are all different. Green, red, purple, all different. Diamonds, all the same. And the pattern inside of it is all the same. They're all striped. So we'll bounce between code here a little bit. So first thing we want to do is open up our web browser and hope this works live. Yeah.
Zoom in a little bit.
To the code, or let's see if I can get a little bit more in there. Okay. All right, we got a browser. It's a good start. And then next step is to activate the get command, which will be your basic hello world. Go to any site that you put the URL to, and looks like we're in good shape. So the next big thing to learn when doing the web data scraping is to use the binding for find element, and they have a lot of different options you can do for this. And basically you'll go into HTML and you'll look for either IDs or names or tags, and you'll be able to find the element and bind that to an object in Python. So for here, we're going to want to pull all the different cards that we can select on the site. And this is what I did. There we go. So you can see it found all 9 cards. I now have a list of 9 elements, and each one represents one of the cards. Just a little overview of finding elements inside the DOM, which if you're familiar with web development, you'll know what that means. If not, don't worry about it. I don't know what it means. So, But generally, you can open up the inspector in your browser of choice. You'll be able to do searches and look for the different objects and different ways to identify them. So things like the ID, the class, etc. And this goes back to my earlier comment about keeping separate browsers. So I'll open up this in Chrome, and then I'll have one browser that is being automated and tested in Python, and the other browser that I'm using for manual stuff. And just some more examples of the different elements that are used on this site. For this, class was huge. And then lower here, just some other from the other project I'll briefly go over for entering in usernames and passwords. Then, most important thing after that is getting element information from the elements. So part of the solver for the set game is being able to define from each of those items what card it is so that the solver can do its solving. A couple different ways. You can get just the inner text. You can get any defined attribute in the HTML. And then even within the element, you can search for sub-elements only within that part of the page. So if there's a bunch of different objects on the page, you can narrow down your search if you know where to look. And we can also do basic navigation, back, forward, refresh, things like that. Missed my slide apparently. There's also clicking, which is also very important for solving the game and interacting. So we'll pick one of the cards. They're not in order the way the site defines it, but of course today it is 0 first. So, so you can see it clicks. It's doing essentially what I would do if I went here on my own. Click them. Then we'll go back here. This is finding information from the element. So you can see it's finding that first card, finding information about the element, specifically the attribute fill, and that fill is red stripes, which as you can see, it's red stripes, so it's working well so far. Also get additional information like the pattern, it's an oval shape. And then just to go over navigating, you can switch sites, we can go back, go forward, and back again. And we'll just refresh. Now just to show you that this, this is what we can do and make it look all fancy. Let's see how this works. So as you can tell, I'm really good at this game now. It's going to go through one more. All right. So as one of my friends said, computers are really good at computing. So, oops. This is just to go over quickly what we just went over, probably really quickly as well. But the original impetus for me getting into this was board gaming site online, being able to pull data, what players did on there, train an AI model, learn how to play it. Did find out the terms and conditions explicitly tell me I'm not allowed to program an AI to play the game on their site. So project's a little on hold. Some of the things I had to do with that site, because it is blocked by authentication. I have to log in. The site sometimes takes a little longer to load. And one of the really neat tricks that I did learn while working on this is instead of just inputting sleep and try accepts all over my code and making it look really ugly, they do have a built-in expected conditions, which is basically just embedded try accepts with sleeps in them for you. But it makes your code look a lot more fancy. So, and then just another item for that is when you start getting into these long lists of data points and pulling them out, list comprehensions are really helpful for getting the elements you can see up here that are being returned by Selenium into usable data for you in Python. And just to go over some of that, this is the site that I'm pulling game data from. I am not logged in, so we will be able to see that here. It's going to tell me I got to go premium to see any of this. So this is kind of where I'm talking about publicly accessible data, looking at terms and conditions. Little questionable that I'm even doing this with the way they word it, but I think I'm okay. I think. So my script, and you can see the whole script on GitHub if you want, has this all embedded. You go to the login, one at a time. You have the send keys object or function. So that's going to send any string for, it's my username and password, so I'm not going to post it here on my code, but I've never made that mistake before. And from there, it'll send it in, and then we can use the login and click that button, and you'll see here, we use one of those expected conditions functions with a wait. And so basically, staleness is looking for that element to no longer exist before moving on to the next step of your code. So I was running into a lot of problems with automation where it would log in, it would try to start looking at things, and it never finished processing my login, and the whole thing came crashing down. So once again, went from a try and accept with sleep and just hoping for the best to something a little more formal. So we'll log in, go back to that page. And this is kind of the meat of the data scraping. I'm not going to go too much into this. There's a lot of conditionals to get the table elements out, which you can see here. So it's going to find the table, it's going to look through all the rows in the table, and it's going to use list comprehensions to output a dictionary. And now we have usable data. So this is the fun part. Now we can do all the Python things we've learned to do everywhere else. A couple of advanced features that are a little useful that I've used in the past. Save screenshot. We've done some work before where we've developed maps in Folium, output those, open it up in WebDriver, and just take a screenshot of it to put it into PowerPoint decks. You can do any kind of keyboard keys, touch actions. There's also things where you can tell the browser that you're using different devices. So for people who are more on the testing side, you can tell that you're using an Android device, and it's going to be able to test your app out on those and mess around. And just to kind of show an example of the screenshot, I took earlier, you can see it takes a screenshot of the page you're on, should roughly match what's up here, roughly. And just here's some links to all the stuff you've seen, Python, the Jupyter Notebook that you just saw, the original scripts. The set one includes the solver and all the code for that. The crawler does everything for the board game site and is not in great shape. I have not developed on it for a long time, so don't judge. Selenium docs are really well written. They're very good. I recommend going to those for advice. And then you can also find these slides on my website. The question is how to deal with random elements. I mean, I think that depends a lot on the use case. So generally, they should all still follow a basic structure when defining things like the class names and things like that.
Let's say that they're not scraper friendly, and they do it on purpose.
They're a large retailer based out of Seattle.
I don't have a lot of thoughts on that. I think that's where you're starting. If they're putting that much effort into stopping you from doing it, I think that gets back to my lawyer slide there.
Purely academic.
You can find some patterns in the page and check if its path will work, like finding some divs or things like that, and then going through XPath or finding a text in the page and then going with it to the element you want to handle. That is it.
That's where I went. Didn't work. I mean,
It works in here, but this it works.
yeah.
You got a question?
So I was dealing with a scraper, web scraper. How do you deal with reCAPTCHA?
I have not dealt with reCAPTCHA. I would probably, if I had to, for a lot of the ones I see now, I would just do the save a screenshot and do some kind of ML function to do image recognition on it and hope for the best.
Actually, Google has gone very smart with the reCAPTCHA now.
Yeah.
Actually, for reCAPTCHA, that's probably had so easy to try to do the audio. They made a machine learning system to bypass the audio.
Have you used any of the headless web drivers, and if so, do you have any recommendations? Which you like the best?
The question was about doing headless. So for those not familiar, that's useful for having a web browser that doesn't have to be visualized. So we've done that a little bit with having Linux machines, EC2 machines run it in the background. I used Gecko driver, same as the one I use for Firefox on my local, and I had a lot of trickiness with it. So I don't have a lot of great advice, but I know Pi Virtual Display library helped a lot with getting that running. There was a question over
You don't have to answer this.
I mean, that's all public information. We're not doing any external scraping in my current company. I currently work at Driven, but in my previous jobs, most of it was just probably similar to what Zach had asked earlier, is going to be kind of retail analysis of our competitors. And so that's still kind of that legal gray area, but it's all public information. They're telling customers their prices, so why can't we look at them automatically multiple times a day?
And any issues that you find with Selenium? I know Beautiful Soup was a recommended way of doing things, and now it seems like Selenium is the preferred method for analyzing web pages.
The main reason I switched to Selenium from things like Beautiful Soup was having to either interact with the page or just needing something to render or have a JavaScript script execute. And I don't know if Beautiful Soup has since figured out something to do with that, but it wasn't working for me in the past.
Thank you.
Thank you.
Thank you.